Hi everyone, so today you're going to learn the physiology of circulation. We've been talking in class about arteries, veins, and capillaries and some unique adaptations that they had to allow them to transport blood and allow for nutrient exchange. So we're going to start with our arteries. Remember they had a thick either muscular or elastic layer to allow for some flexibility with changes in pressure. Remember these are subject to huge pressure variations that veins are not. One of the adaptations of veins was that they had valves. And what the valves would do would prevent backflow. Remember, we want all the blood going in one direction. It's a one-way street, not a two-way street. What we did not completely talk about in class, but we will now, is capillaries and why they are the way they are. So remember, capillaries are a single cell layer thick. And are designed for nutrient exchange. Now this presents some challenges. It's easier to exchange nutrients through a single cell layer than a brick wall, but what this presents from a challenge standpoint is they're very delicate and then can potentially rupture. So there's always a trade-off. There's always give and take when we're talking about different aspects of anatomy and physiology, and this is definitely a trade-off, okay? Because your veins, blood is moving somewhat slowly through your veins when you compare it to the speed at which or velocity at which it's moving through your arteries. At any given time, about 50% of your blood is actually tied up in some of your larger leg veins. To get past the valves, we need to rely on muscle contraction and the muscles around the veins and around the valves. That muscle contraction, every time you move those muscles, is going to push more and more blood past the veins so that you can return it back to the heart. Okay?